Hello guys, today's lead code problem is minimum number of steps to make two strings anagram. Yeah, you are given with two strings, namely S and T. In one step, the given conditions of swapping the characters are in one step you can choose any character of T. So you can choose any character in T and replace it with another character, any character you want. Okay, so that you can do as many operations you want, and at last you have to make sure that the two strings S and T are anagram to each other. So in so that so the main concept of this question is we have to make two strings anagram. So by taking minimum number of steps, okay. So we have to return the minimum number of steps to make T and S as anagram. Okay. So what is an anagram here? Like anagram is a string. So anagram form, the two strings are said to be anagram. Okay. For example, if we take these two strings, so the count of B in a string is 2 and A is 1. Okay. But in T string, the count of A is 2 and B is equal to 1. So whenever the count of characters are equal in both the strings, then it is called an anagram. Okay. So for example, we can say A, B, B, C, D, C, C, S, C, and this is an string, and C, A, B, B, A, S, C, B. These two are anagrams. Why? Because the count of characters in both strings are equal. Like the count of the frequency of single characters. Like the frequency of each character in string S and frequency of each character in string T are equal here. Like so, for example, in this string, the frequency of characters are A is equals to 3, A is equals to 3, and B is also equal to 3, and C equal to 2, and S equal to 1. Okay. Now we have to count for the T character here. So for example, if we count the A characters here, 1, 2, and 3. So it is matching with the string S A characters, right? The frequency of string S A character is equal to the frequency of the string S T string T A character, right? And B frequency is also 3 in T character. C frequency is 2 here, and C frequency is 2 here. In both the string S and T are equal, and S frequency is 1 and S frequency is also 1. So we can say that these two are anagrams to each other. In this way, we need this. This is called anagram here. So how many minimum operations we need so that the two strings are anagram to each other? So here, and T is equal to 1 in string S. The frequency character map is in this way: B is equal to 2, A is equal to 2, and T has A equal to 2 and b equal to 1. So here, to make t string anagram to s, we have to swap one character of a with b, right? So when we swap one character with one character of a with b, then the frequency of will become in this way, right? So in this way we can, so the minimum operations here are only one, right? So one swap is required here, like one character replacement is required here, so that so the minimum operations are one here. So how we can achieve this problem here? Okay, so how we can achieve is like we have to take another example. We will take another example here, and if we consider this example, lead code anti, so we have to map the we have to map the we have to take a hash map here and map its character to frequency here. So when we map a string here, L comes to 1 and E comes to 1 and E comes to 2 and T frequency comes to 1 and C frequency comes to 1 and O frequency comes to 1 and D frequency comes to 1 and E frequency comes to 3, right? So in this way, the hash map character comma integer takes place here. Now, while iterating over string t, we have to take a variable answer equal to 0, and we have to count. If character is present in hash map, then there is a matching of that character, right? So we need to decrease the frequency of that character in hash map. Okay, so whenever it is not matching with the character, whenever, see, we have two conditions here, right? If tchar is present in hash, else it is not present in hash, right? This is a pseudocode here. If it is present in hash, what we have to do? We have to decrease the frequency count of that character, right? Right? We have to decrease the frequency count in that of the character, right? So we will decrease the frequency character here. So whenever the character is present in hash map, we need to decrease the frequency character, right? Frequency of that character in hash map. Else we need to, it is not present in hash map. So it is not present in S only. So we need to add it, right? We need to add it. So we will increase our answer value here. So we need one operation to add it, right? So we need one operation to add it. So we will increase our answer variable here. So in this answer plus plus we will do. So if tchar is present in hash, okay, if tchar is present in hash, we can directly decrease the frequency of that character, right? Okay, now, and another condition here we need to check is if the frequency character is equal to 1, okay, and we have to remove one character, okay. So when frequency character of when hash map contains a character and it has the frequency of 1, then we need to permanently delete it from hash map so that we don't, whenever, see, why? Because, see, when no, Now observe that case here. Now if P is not present in the character, so answer will become 1, right? Now R is present in the character hash map. No, R is also not present in the hash map, so we need to increase our answer variable here. Is A is present in the hash map? No, A is not present in the hash map. We need to increase the answer variable here. C is present in hash map. Yes, C is present in hash map, so we need to decrease the C value to 0 here. Okay, and T is present in hash map. Yes, it is T is present in hash map, so we need to decrease the T value, T frequency to -1, right? Like we have to decrease the frequency of that character by -1. Okay, is I present in hash map? No, I is not present in hash map, so we need to increase the answer variable here. Is C present in hash map? Yes, it is present, but we are doing C. If C present in hash map, it is present in hash map, but it is not present in S. Why? Because we have already made a match with that character, right? So here in hash map it is present, but S it is not present, right? So for this type of case, whenever the frequency count of character is equal to 1, then we need to permanently delete it from hash map, so that whenever that same character appears once again in the T map, so it doesn't match and it doesn't make the character frequency to negative frequency, right? So in this case this is not present, right? C frequency is 0 means it is not present in S, right? So in that case we can directly delete it from hash map, right? So whenever we need to have a check here, whenever tchar dot get is equal to 1, then hash dot remove t dot char. Okay, or else tchar hash dot get tchar hash dot frequency of tchar minus minus, right? Else we can decrease the frequency of the character, right? We have understood this case, right? If the frequency of the character is equal to 1, then we need to permanently delete it. Why? Because if at all it again appears in the character in the T string, it is present in hash map, but it in general it is not present in S, right? Because the frequency of character will be 0 in hash map. So to handle this case, whenever the frequency of character is equal to 1, we need to directly delete it from hash map, so that we can handle this case perfectly here. Okay, and now C is present, so we need to decrease the character. T is present, we need to decrease the character. I is present, I is not present, we increase that answer variable, right? Is C is present, C is present, is C is present? No, right? So we need to increase our character here. Okay, increase the answer variable here. Is E is present? Yes, it is E is present. So we need to uh, decrease the frequency of that character, right? In this way, we can do the we can do this answer. We can do this question here. Like, okay, understood the pseudocode here. Okay, if any doubts, you can post it in the comment section below. I will be answering your questions. Okay, and coming to the code of this solution, this is the code here, and I have taken a hash map here, and I have stored the frequency character. Okay, frequency of the character in hash map, and I've taken an answer variable here, and I've iterated over t character here, and the same thing. If the character is present in hash map, then I have to do something, right? I've did something here. If the character frequency is equal to 1, I have permanently deleted it from hash map, or else I have deleted the frequency by -1, okay? Or else I have increased the answer variable here. At last I have written the answer here. So this is the solution here. Coming to the TC here, it is big of n here, and coming to the space here, big of n here, and we can still optimize this solution here. We can decrease the space complexity to big of n. How is that possible is, instead of taking the hash map here, we can take the int array here, int int array. We can show the character frequency in the array here, and we can do this like 26. 26 is equal to big of 1 only, right? So in this way we can optimize the space complexity here. Yeah, this way we can optimize this space complexity. Thank you.